Alright, so if we look at 4.5, and we're looking at our graphs of sine and cosine, these are our parent graphs of sine and cosine, meaning those are our graphs that have no transformations done to them. And I highlighted your period in green. So I've graphed only the major points, which are the points on your unit circle. So your endpoints on your unit circle for both sine and cosine. Okay, so on your graphs of sine and cosine, this is what your standard graph of sine looks like, meaning it starts at 0, ends at 0 after one period. And we always graph our key points only because these are the ones that are easy to graph. So when you're drawing your graphs, you're going to graph points pi over 2 pi, 3 pi over 2, and 2 pi. Because those are the ones that are really easy to find on your unit circle. And they're easy to find because they're your endpoints. So they're like this point right here, this point up here, this one, and these ones. They're only your like endpoints of your circle, so that's why they're the ones that are easy to find. Okay, so that's why we want it to be easiest for you if you use your unit circle on this assignment when you're graphing. Alright, so let's graph y equals 2 sine of x from negative pi to 4 pi. Okay, so if I'm looking at my unit circle and I go to negative pi, which means I'm going backwards to pi, I'm going to end up just at pi. And so my sine value is my y value. So what is my y value at pi, based on your unit circle? Y value. 0. 0. Okay, so I know that my y value is 0, and 2 times 0 just gives me 0. So I know that at negative pi, I'm going to have a value of 0. Okay, if I go to negative pi over 2, that's like going backwards pi over 2, so I'm going to end up at 3 pi over 2. So what's my y value at 3 pi over 2? Because I'm going backwards from here to negative pi over 2, which actually puts me at 3 pi over 2. Because pi over 2, but then we flip it to make it negative. So negative 1. And then we're taking that times 2, so it's actually negative 2. So my amplitude on this one goes from negative 2 to 2 instead of going from 1 to 1 like the first graph did. It won't necessarily change the shape of the graph though. Okay, and then at pi over 2, what's going to be my sine value?
Zero.
What, your sine value is your y value, and so 1 times 2 gives me 2, so I know I'm going to be up at 2. Okay, and what's my sine value at pi?
Negative. That's sine's x value, right?
Sine's your y value.
0.
0. Okay, and 0 times 2 just gives me 0. At 3 pi over 2, what's my sine value? Okay, and negative 1 times 2 gives me negative 2, so I'm going to be back down here. At 2 pi, what's my sine value? 0, yep, and then you notice the pattern, they're just flip-flopping, so it goes up, down, down, up. That's always going to be your pattern for your sine curves. So then, oh, I graphed that in the wrong spot, didn't I? That was supposed to be here. No wonder I was confused. So then if I connect my dots, I'm going to end up with a curve that looks like that. And that's going to be your sine curve, where it's just going to keep going back and forth, up and down, in between negative 2 and 2. Okay, so let's graph a cosine curve next. So we're going to graph 3 cosine of x. And this 3 then tells me that I'm going to be graphing between 3 and negative 3. That's what changes my amplitude. So if I'm changing my 3, I'm still just going to graph them, and I'm using points. Negative pi over 2 to 9 pi over 2. And so your cosine value is always your x value on your ordered pairs. So if I go to negative pi over 2, which means I go to pi over 2 and then flip to the bottom, what's going to be my cosine value? If you go to pi over 2, and then, so pi over 2 is at the top of your circle, we're looking for negative pi over 2, so then we flip to the bottom. So cosine is 0. Okay, so my first value starts at 0. And this is 0, my origin 0. So what is my cosine value at 0? Cosine's your x. So at 0, you should be at 1, and then 1 times 3 is 3, so that's why we're up at an amplitude of 3. Okay, what about my cosine value at pi over 2? 0. And my cosine value at pi? Negative 1, which is like negative 3 because we have an amplitude of 3. And then at 3 pi over 2, 0. And then we just keep repeating those same values, so it's going to go alternate between going up and going down the whole way. And then we just connect them. So your cosine graph of y equals 3 cosine of x, something like that. Cosine, sine. Alright, so graphing's not so bad. You use your unit circle. I mentioned amplitude a couple of times because we were changing our amplitude of our graph, and amplitude's how high and low you go on your graph. And they're always going to be the same unless we do some type of shift. And so amplitude is going to be the square root of a, where a is the number out in front of your graph. Thank you. Thank you.
What's that?
Graduation orders. Yeah, bring to your conferences. Alright, and then period was the second part of what was on your graph, and we didn't talk about that on the last two, but it was on the first slide of your notes. And period is usually 2 pi, unless you are doing something to your x, in which case your period changes to 2 pi divided by b. And b is the number going to be in front of your x. So, if I look at example 2a, it says find the period and amplitude. And amplitude is always the square root of a. And in this case, what's going to be our a value? We're multiplying this whole thing by 1/2, so my a value is going to be 1/2, and the square root of, the absolute value of 1/2 is just 1/2. So I know that my amplitude is just going to be 1/2, so that tells me that I'm going up 1/2 and down to negative 1/2 on my graph. Your period is whatever changes based on whatever you're multiplying your x by. So your period is always 2 pi divided by b. But in this case, we're not multiplying x by anything. There's nothing inside that x. So your period just stays 2 pi. So as long as you're not multiplying your x by anything, your period will always be 2 pi. And that tells me how often my graph repeats. So every period, then your graph just starts doing the same thing. Okay, so I do the same thing for 2b, y equals 1/3 sine of x. To find my amplitude, I'm taking the absolute value of a, And in this case, then I'm taking the absolute value of 1/3. And what is the absolute value of 1/3? 1/3. So my amplitude is 1/3. So I'm going to go up to 1/3 and down to negative 1/3 on my graph. That's what that means. Second part is finding your period. And your period is found by 2 pi divided by b. But in this case, there is no b. I mean, b is 1. So your period just stays 2 pi. We're not multiplying x by anything. Okay, and probably 90% of the time your period is just always going to be 2 pi, because that's the standard period. Alright, and then if we do one more, we're going to find our period and amplitude. Amplitude is the number out front, so square root of a. In this case, our a is just 1. There is no number out front, so square root of 1, or absolute value of 1, I mean. Absolute value of 1 is just 1. So I know my amplitude is 1. To find my period is 2 pi divided by b. And if I rewrite x over 2, I can rewrite x over 2 to be 1/2 x. It means the same thing, which means that my b is 1/2. So to find my period, then I get 2 pi divided by 1/2. And we can't divide by fractions, so we have to leave it, change it to multiplication, and flip my fraction to be 2 over 1. And 2 pi times 2 over 1 gives me 4 pi. So in this case, my period would be 4 pi. So hopefully that makes sense. And then the last thing we're going to look at is we're going to look at horizontal shifts and vertical shifts of your graph. So a horizontal shift is when you're moving your graph left or right on your x-axis. A vertical shift is when you're moving it up or down on your y-axis. Alright, so for a horizontal shift, you have 2 endpoints. You have your one to the left, which is where your function equals 0, and one to the right, which is where your function equals 2 pi. Because that's your period. Your period always runs from 0 to 2 pi. And so you take whatever in your parentheses and you set it equal to those two, and then you solve it for x. And that will tell you your endpoints on your x-axis. A vertical shift is a lot easier than that because you're simply looking at what you're adding or subtracting from your function, and that tells you whether or not you're going up or down. So if d is positive, you're going up. If d is negative, you're going down. Okay. So if I look at example 4, I'm trying to figure out my endpoints of my graph. And so I know that I have an amplitude of 1/2. So that tells me that no matter what, my graph's never going to go above 1/2 or below 1/2, negative 1/2. To figure out my endpoints, I know that I have to set x minus pi over 2 equal to 0, and x minus pi over 2 equal to 2 pi, and I have to solve those for x. So if I start with the first one, in order to get rid of a minus pi over 2, I add pi over 2. So I know that x equals pi over 2. So that's my first endpoint. For my second one, I do the same thing. I add pi over 2. And if I do that, this is like 2.5 pi over 2, which is like 5 pi over 2. So those are my 2 endpoints. So then if I want to graph my graph, I know that my amplitude amplitude tells me I'm going from 1/2 to -1/2 on my y-axis. That's what your amplitude tells you. The second part of our graph tells us that our endpoints are pi over 2 and 5 pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. Okay, and I also know that from my parent function, the sine always starts at 0. So I know that I'm going to start at pi over 2 at 0. And then you just do everything so that you know your sine function starts by going up, going back down to 0, going down, going back up to 0. So for this particular horizontal shift and period, your sine function is like that. Alright, if we look at 5a, y equals -3 cosine of 2 pi x plus 4 pi. So I know that a is my amplitude, so I'm going to go between 3 and -3. To find my endpoints, I set 2 pi x plus 4 pi equal to 0, and 2 pi x plus 4 pi equal to 2 pi. And then I solve them. So I start by subtracting 4 pi from both sides. So 2 pi x equals -4 pi. If I divide by 2, then x equals -2 pi. So that's going to be my first endpoint, my one furthest to the left. If I do that again, subtracting 4 pi from both sides, I get 2 pi x equals -2 pi, because 2 minus 4 is -2. And if I divide by 2 pi, divide by 2 pi, and I get x equals -1 pi or -pi to be my last endpoint. Okay, so if I go to draw my graph, this one, I'm doing negatives, so I'll put it over here. I know that I'm going to go from 3 to -3. And I also know that my period was from -2 pi to -pi. And I'm not going to worry too much about labeling the other middle points, but I know that I have to have 5 points total. So 1, 2, 3, 4, 5. So your 2 endpoints and 3 in the middle. Yeah, you always start with 5 points. 1, 2, 3, 4, 5. There's always 5. So you can, if you want to do them, if you want to label these ones in the middle, you can, but you certainly don't have to. You just have to label your endpoints. So if I label my endpoints, and I know that sine always starts where? 0. Sine always starts at 0, so we're going to start at 0. And then what direction does sine go? Up. So I know that I'm going to go up, and back. Cosine starts up. Cosine starts up and then goes down. Oh, this is cosine? Oh, I see what you're saying. I thought I was still graphing sine, so I'm following your thought process now. Okay, you're right. Cosine always starts up, so I'm going to start up, then I'm going to go down. And then once I hit the bottom, then I go back up. So then, this 3 cosine of 2 pi x plus 4 pi looks like that. Start up and then go down. That's how cosine always works. Alright. So let's do one more. So we're given negative 1/2 sine of pi over x plus pi. So I know that A is my amplitude. So negative 1/2 is my amplitude. And then to find my endpoints, I have to set them equal to 0 and to 2 pi. So if I set it equal to 0, subtract pi. So pi over x equals negative pi. Divide by pi. X equals negative 1 is my first endpoint. Then if I do the same thing, subtract by pi over pi x equals pi. Divide by pi, x equals 1. So then if I graph that, y and x, my period goes from negative 1 to 1. My amplitude is 1/2 to negative 1/2. And I know that I have to have 5 points in the middle, and 0 counts as a point. So then I'm graphing sine, and sine always starts where?
Yeah.
0. And which direction does it go? Up. So then I add my 5 points and connect my line. Alright, so you guys are going to work through 326, 11 through 26, 39 through 50.